So shall I start? Am I audible? Am I audible? Hello? Hello? Okay, I don't know. No response. Show that density of a gas is directly proportional to pressure. Hello, am I audible?
Yes, sir.
Oh, okay, right. So PV is equal to nRT. We'll use this equation. We had to show that density of the gas is directly proportional to pressure. Now we have P is equal to N by V RT. So that condition we had to do. So N is what? Weight by gram molecular weight into 1 by V RT. Okay. Now P is equal to, we will rearrange here W by V and రాసుకుంటాం into 1 by M పెడదాం into RT. Okay. W by V is what? Weight by volume, that is density, right? So we get dRT divided by M. For a given gas M, R, T are constant when we fix temperature. When we fix temperature, MRT are constant, right? So P is equal to dRT by M. Okay, this is also very important relation. So we can directly write pressure is directly proportional to density. Pressure is directly proportional to density. So I can write this. This is the first question. Clear?
Yes, sir.
Yeah. Next one. Question number 2. 35 ml of oxygen, 35 ml of O2 is collected at 6 degrees centigrade. Is collected at 6 degrees centigrade and 758 mm of pressure. 758 mm of Hg pressure. Okay. Calculate its volume at STP. There is a question. Calculate its volume at STP. Now we'll write V1 is 35 ml, and we have T1 is 6 degrees centigrade. 6 plus 273 we have to put. So that will be 279 Kelvin. Now that is V1, T1. And what is T1? That is 758 mm of Hg. This is the first one. Next, V2. What will be the volume at STP? V2 we have to find. And T2. At STP, what is the temperature? 273 Kelvin. STP. And now P2. That is at STP, the pressure will be 760 mm of Hg. ఇది తెలుసుండాలమ్మా. mm of Hg లో చెప్పాలంటే pressure at STP is 760 mm of Hg. These are STP conditions, standard temperature pressure. Temperature pressure conditions are like this. Okay. Now, what is the equation? P1 V1 by T1 is equal to P2 V2 by T2. This is what we'll do. Now, V2 we have to find. V2 is equal to T1 V1 T2 divided by T1 V2. T1, what is this? T1 P2. Substitute the things. That's it. P1 758. B1, that is 35. T2 273 divided by T1 279 into P2. P2 is 760. So V2 is what we need. So V2 is about 34.16 ml of cinema. Once we calculate 34.16 ml is what we get.
Noted, sir.
Okay, right. Very good. Now the next one. Next question. Now, another question. A mixture of dihydrogen, I will write it H2, and oxygen at 1 bar pressure, at 1 bar pressure contains 20% by weight contains 20% by weight of dihydrogen. Dihydrogen. Okay. Calculate the partial pressure of dihydrogen. Calculate the partial pressure of H2, assuming ideal behavior. This is very important. We had to assume ideal behavior and solve this problem. I think Gurtunchukovalama. So this is what generally in the IIT level they will ask like this. Now, what are the things given? See, a mixture of H2 and O2 contains 20% weight of hydrogen. Okay. So to start with, the problems and illa start chesaru. Let the given mixture be 100 grams in total. So this is general start. Let the given mixture, if they ask you some percentage type problems, this is how we start. Let the given mixture be 100 grams in total. Okay. Now, it contains 20% by weight of hydrogen, which means weight of hydrogen means 20% of 100 grams, that is 20 grams. Okay. Similarly, what will be the weight of oxygen? 80 grams. Clear? This is how we start when percentages are given like this. Now, once we have this, what is the number of moles of hydrogen? Weight of hydrogen by gram molecular weight of hydrogen. Hydrogen is, each is 1. Hydrogen is 1. So 1 plus 1 is 2. 2 hydrogens are there. So divided by 2. So you get 10 moles. Okay, this is the first part. And similarly, you have NO2, which is 80 by, each oxygen is 16. So you get divided by 32. 80 by 32. So this is 16 to 16 5s are 80, right? 5 by 2. So that is 2.5 moles. So oxygen we got. After this, to calculate the partial pressure, we need mole fractions. Mole fraction of hydrogen. Mole fraction of hydrogen is NH2 divided by number of moles of H2 divided by number of moles of H2 plus number of moles of O2. This is how we calculate. So number of moles of H2 is 10 moles, sorry, 10 divided by 10 plus 2.5. So that is 10 by 12.5. So this is what you have. Okay, so this works about 0.8. Okay, 0.8 moles hydrogen, and that of oxygen XO2, that will be, you calculate that what you get is 0.2 you will get. Okay, endavarku note cheyandama. Note it up to here.
Noted.
Okay, very good. Right. Now, mole fraction of hydrogen is 0.8. Mole fraction of O2 is 0.2. First mole fractions calculate చేసుకోవాలి. Then partial pressure. Partial pressure of hydrogen is like this will write. Partial pressure of hydrogen is XH2 into P total. What is the total pressure? Total pressure ante icharamma? P total. The mixture is at 1 bar pressure and icharu. Okay, mixture is at 1 bar pressure. So XH2 is 0.8 and they have given it as 1 bar. So the partial pressure of hydrogen is 0.8 bar. Now similarly, partial pressure of O2 is XO2 into P total. XO2 ఎంత వచ్చింది? 0.2 into 1 bar pressure. So that is 0.2 bar.
Noted, sir.
Very good. No. Now the next question. Draw the curves. Draw the curves. Log P versus log V and log V versus log T. So logarithm based question this is. So how do we answer this? This is little bit typical type of question. So for this, first of all, we have to know something. Log P versus log V. So here we have PV is equal to constant. What is this? Boyle's law, right? So we can write PV is equal to some K. So P is equal to K by V. First write this. Now P is equal to K by V. Now I will take log on both sides. Log P is equal to log K by V. So we have a formula log M by N is nothing but log M minus log N. Using this formula, we can write this as log K minus log V. Of course, you have logarithms in syllabus. Next thing I'll start cheddam because you are looking for, I came to know that you are looking for logarithms. I will start that after this. Okay. I will try to finish off this chapter and then try to finish off this today and then I'll start logarithms. Okay. So this is log K minus log V, log P. So we have how the curve looks like. This we have to compare with log P ni Y అనుకుందాం. Y is equal to log V ని ఇక్కడ minus log V ఉంది. Minus mx plus c. ఈ type. This is the equation of straight line. So equation of straight line తో compare చేసినప్పుడు we get the curve like this. Generally logarithms తీసుకున్నప్పుడు మనకు straight lines generate అవుతుంటాయి curves. Logarithmic curves generally straight lines generate అవుతాయి. ఇప్పుడు మీకు ఇది curve తీసుకున్న negative slope. This is a curve with negative slope. So it comes like this. Okay. I don't know why it's not coming. Turns up to be like this, something like this. Okay. So here we go. So you get log P versus log P. So this is how you get. This is the curve straight line with negative slope. Straight line with negative slope. Negative slope అంటే ఎంత స్లోప్ ఉంటుంది? -1. Slope is -1. Okay. Slope value is -1. సో ఈ స్ట్రైట్ లైన్స్ మీలో మీకు మళ్ళీ ఎక్స్ప్లెయిన్ చేస్తాను. ఐ థింక్ ఐ డిడ్ స్ట్రైట్ లైన్స్ వన్స్ if I remember correctly. Otherwise we'll do it one more time, no problem. Straight line with negative slope. Slope is -1.
Noted, sir.
Okay, now how does the other curve looks like? So that is log b versus log t మనం చేయాలి. So for that we have Charles law, v by t is constant. So it is like v by t is equal to some k. So v is equal to kt. So you have log v is equal to log kt. So you have log mn is equal to log m plus log n. So using this formula, we'll solve this. So we have log v is equal to log k plus log t. So how does this curve looks like? Log v versus log t curve. Okay. So it's something like this. Okay. This is log v versus log t. This is a straight line with positive slope. Straight line with positive slope. That's all we can tell.
Noted, sir.
Okay, very good. Now we'll do this next question. Now 135 ml of a gas, 135 ml of a gas is collected over water, is collected over water at 25 degrees centigrade. At 25 degrees centigrade and 0.993 bar. 0.993 bar. Okay. If the gas weighs, if the gas weighs, if the gas weighs 0.160 grams, 0.160 grams, and aqueous tension and aqueous tension at 25 degrees centigrade, at 25 degrees centigrade is 0.0317. 0.0317. Calculate molar mass of the gas. Calculate molar mass of the gas. This is the question. So 135 ml of gas is collected over water at 25 degrees centigrade at this pressure. Now the gas weighs 0.160 grams and aqueous tension ఇచ్చినప్పుడు మనం ఏం చేయాలి? Pressure of the dry gas is pressure minus aqueous tension. ఇది చేయాలి. So we need the pressure of gas, pressure of dry gas is equal to pressure of wet gas minus aqueous tension. దాన్నే pH2 అంటారు. pH2 అని aqueous tension. Aqueous tension. So what is the pressure of the wet gas? That is 0.993 bar minus aqueous tension. This is also bar they have given. That is 0.0317 bar. So what is the pressure of the dry gas? That is the pressure of actual gas. Actual pressure of the gas. So that happens to be 0.9613 bar. So this is the pressure of the dry gas. Now I use the equation PV is equal to nRT. Now here when substituting P, this is the P, 0.9613 into V. What is the volume? 135 ml. There is a volume. Now we need the number of mole. We need the what is the molar mass we need. So weight of the gas divided by molecular weight, that is number of moles into RT. Right? Molar mass manaku kavali. Molar mass is nothing but WRT divided by PV, actual equation. So we'll substitute the things. What is the weight? 0.16, right? R is 0.08. So it's given in bar kada. So the R value is 0.083 use cheyali. 0.83 for bars. Okay. And the temperature 25, that is 298 Kelvin వస్తుంది మన temperature. Whole divided by pressure 0.9613 into 135 ml undi. So that we had to convert into liters, 10 power minus 3 liters. Okay, so with that మీకు R value గుర్తుండాలమ్మా, 0.083 liter bar mole inverse Kelvin inverse, and R value is 0.0821 liter atmosphere mole inverse Kelvin inverse. ఈ కన్వర్షన్ ఫ్యాక్టర్ మీకు మైండ్లో ఉండాలి while solving the problems. So you get the molar mass of the gas about 30.49 gram mole inverse. 30.49 gram mole inverse. This is what you get.
Noted, sir.
Okay, good. Now we'll go ahead. అమ్మా ఇవాళ మీకు టైం ఉందా? డూ వీ హ్యావ్ సమ్ టైం లైక్ కొంచెం టైం ఉంటుందా ఇవాళ? అంటే another 40 minutes do we get or you are busy today? ఎందుకంటే సాటర్డే కాబట్టి నాకు కొంచెం ఫ్రీ టైం ఉంది అందుకని అడుగుతున్నాం. హలో హలో
We have school, sir.
స్కూల్ ఉందా? ఓకే ఓకే, విల్ క్లోజ్ దెన్ టుడే. We'll close then, and then one problem we'll do. We'll close today. I'm fine. Okay, here itself will stop. This is sufficient, I hope. ఇంకేదైనా ఉంటే మళ్ళీ చూద్దాం. A 5-liter vessel. A 5-liter vessel contains 1.4 grams of nitrogen. Contains 1.4 grams of nitrogen. When heated to 1800 Kelvin, 30% of molecules, 30% of molecules are dissociated into atoms. Or dissociated into atoms. Calculate the pressure of the gas at 1800 Kelvin. Calculate the pressure of the gas at 1800 Kelvin. So this is the question. So how do we answer this? So nitrogen, వాళ్ళు ఏమంటున్నారంటే nitrogen, it dissociates into 2 nitrogen atoms. Okay. So initially 1.4 grams of nitrogen. So initially there will be 1.4 divided by 28. That will be number of moles. So that is about 0.05 moles ఉంటుంది. Moles of nitrogen, and there is nothing first initially. So the next one is 1800 Kelvin తర్వాత. This is the initial case. Now final case, when you go to the final case, 30% is dissociated. Only 70% of this remains. So that is 0.05 into 70% is here, and 0.05 into 30% is here. Okay, so that's how we calculate. So here, but 0.05 into 30%, but 2 nitrogens are there, so we multiply with 2. Okay, so that works out to be 60% of nitrogen. ఎందుకంటే 2 వేసామంటే ఇక్కడ 2 nitrogen N2 కాస్త 2N గా స్ప్లిట్ అవుతుంది కాబట్టి we'll write 2 over here. Okay, so now total number of moles మీరు calculate చేస్తే total number of moles, if you calculate, that works out to be 0.06, 0.035. This will be 70% of 0.05 మీరు calculate చేస్తే 0.035 వస్తుంది. Plus this will be like 0.03 వస్తుంది మీకు. This will be, yeah, 0.03, yes. ఎందుకంటే 6 5 30, so this is 0.03. So this 0.065, right? So this is what you get, total number of moles. So once you get the total number of moles, you can use the equation PV equal to nRT. P is equal to nRT by V. So N is 0.065. Our value is 0.0821. Okay, we'll put that into temperature is 1800 divided by V. 5 liter vessel, you have 5 liters. Okay, you have 5 liters. Okay. So this pressure, that's what the calculation is. Okay. So 1.92 atmospheres is what you get. Hence the answer. Yeah, sufficient today. So with this, we'll complete the chapter. Level 1. Next part is kinetic theory of gases. Kinetic theory of gases will deal that later. Next part will deal one more time. Next, liquid state is a big one. One by one, we'll come back to this. Okay. Thermodynamics is also the thermodynamics is there. We'll come back. Okay, clear?
Clear.
Okay, ma. We'll leave. Next class will be on Monday then. Bye. See you all.